Okay, welcome to guide sheet number 2 for static electricity. We'll be dealing with different materials, insulators, conductors, and then we'll look at how certain items can be polarized. The insulators are different than conductors in that insulators, now everything contains electrons and protons. Everything contains charge. The difference is the nature of the movement of that charge. Insulators are things that do not easily allow the electrons, the charge, to move around. So actually we say they have a higher affinity for electrons. They tend to hang on to the electrons and not let them move easily from atom to atom. If a material can easily allow the electrons to move, we call them conductors. To conduct, to allow to go through. Typically, items on the left-hand side of the periodic table, the metals are good conductors of electricity and heat, and then the non-metals on the right-hand side are insulators. Typically, they do not easily allow the electrons to move. On the right-hand side, okay, so over here on the right, we have a sphere that is negatively charged. So we have electrons built up on it, and they're going to want to get away from each other. So we're touching various objects, and we want to see if those objects should allow charge to flow through it when we do that particular object. Now, a plastic straw, plastics typically have a high electron affinity and therefore are typically insulators, so it would not easily allow it to go through. Piece of paper, same kind of thing. Paper is an item made up of cloth and items that tend to not easily allow electrons to pass through. A steel house key is a metal. It will definitely let the electrons travel easily. A metal paperclip. Metals, again, are good conductors. And aluminum foil. Those are all good conductors of electricity as well as heat. Okay, so here we have a picture of two spheres. The one on the right has the charge spreading out evenly throughout, and they are on the surface of the material. On the one on the left, we have three different distinct areas of charge. That's going to make this item, which can have the electrons or the charge not be moving around, an insulator. And that's going to make this item a conductor. Now that brings up an important element of a spherical conductor. Inside the spherical conductor, there is no charge. The charge will naturally spread out, trying to get away from each other, will spread out on the surface of the conductor. So it will not go inside the metal conductor. That makes a metal car a very safe place to be in a lightning storm, because the lightning, even if it should strike your car, would not go inside to where you would be located. So keep that in mind. Again, insulator can build up charge in specific places. Conductors, the charge will always spread out on the surface. 5 is false. You can charge conductors with frictional rubbing. It's just a little tougher because you have to make sure that you don't touch the conductor with anything that might conduct away the electrons that you're trying to build up. So it can be done. It's just a little more difficult. 6, we charge up the balloon with rubbing it with animal fur. The fur is going to transfer electrons to the balloon, has a higher affinity, so we're going to get a negative charge on the surface of the balloon. If we bring it over toward the wood cabinet, we can get it to stick. And the reason it's going to stick is that at the surface of the wood, the positive charges are going to be left behind, and the negative charges are going to tend to be pushed away. This separation of charge is called polarization, and it's the wood molecules that are going to polarize. And really it's the atoms themselves. The electrons in the atoms of the wood are going to spend more time on the right-hand side of the atom than they would on the left-hand side of the atom from our picture. So that surface near the balloon will be oppositely charged, and the balloon will be able to stick to the wall. That effect of being able to polarize is most often noticed in conductors. Conductors are very good at polarization because not only could you polarize the atoms at the surface, you can actually get electrons to move to the other side of the material. It does happen in insulators, but it's not as thorough, and it's definitely not as common. Okay, so we have a negatively charged balloon again. We're going to bring it near this neutral conducting sphere, as shown to the right. So again, opposites attract, likes repel. Again, protons are not what's going to move. It's going to be the electrons that move. So what we're going to see is we're going to end up with positive charge on this side and negative charge on this side. Not because the protons are pulled to the left, but because the electrons are repelled to the right. So the electrons in the sphere will move to the right-hand side, away from the other electrons that are on the balloon. Again, that process is known as polarization. So the process of inducing the movement of charge within a sphere, causing positive and negative charge to be separated, is known as polarization. You probably think of poles most often with magnets. You have a north and a south pole. Well, with electricity, we can have a positive and a negative pole. We've turned it into two separate poles. Okay. Charge rubber rods are placed near a neutral conducting sphere. Again, it's a conducting sphere, causing the redistribution of charge on the spheres, which would show the proper distribution in this case. So diagram A, the negatives are pushing away the other electrons, and so that's one we've already seen. Here you would not have the likes together, so that wouldn't work. Here you would not have the likes together, so that wouldn't work. Here we do a positive, and then the negatives are next to it. So what would have happened is the electrons would have been pulled across there, and that is perfectly legitimate. Here we would pull negatives toward the protons, toward the positive charge, but that means we would have to leave behind positive. This again is an offshoot of conservation of charge. The charge within the sphere has to stay equal, positive and negative. All we're doing is separating them into two different poles. I couldn't just get negative charge on the conducting sphere by bringing a positive charge near it. I can only separate it temporarily into two different poles. Okay, so in the above situation, the conducting sphere is, and then the ones that work, the conducting sphere is called, it's polarized. So the process is called polarization. When a sphere has this separation of charge, we call it a polarized sphere. One of the activities that I hope we've done is to use a charged balloon or a rubber rod to make water move toward it. The reason that works is that the water itself looks like a little Mickey Mouse, and it's actually a polar molecule, which means it has more charge on one side than the other. So as the molecules fall down toward the ground, they would fall straight, but by bringing a charge nearby, the one part of the molecule will be more attracted to the left than the other, and you'll actually get the water molecule to pull toward your charge, whatever that charge may be. And again, this is what we saw earlier. In terms of the balloon, the surface of the balloon would be negatively charged. We've rubbed it with animal fur. Then at the surface of the wood, the actual atoms at the surface would become polarized. So we'd leave behind positive charge, and then we would end up with negative charge. The electrons would end up spending most of their time on the right-hand side of the atom, the atoms of wood, the molecules of wood, and so we would get that separation. Now the plus, and it's nice to use blue for positive. Typically blue and black are used for negative, sorry. Red for positive, blue or black for negative. So again, on the battery of your car, The negative terminal, which is attached to the ground, is black, and the positive terminal is red. So these two will now attract, and the balloon can stick to the wood wall. It didn't charge the wood wall, it simply polarized the surface of the wood wall. Okay, that's it for polarization and conductors versus insulators. They do behave very differently. Essentially, the conductors and insulators are exactly the reverse of each other. And then polarization is something we will use to get a number of things done in both insulators and conductors.